Here we're going to go through these 4 steps in order to solve this system of equations using the elimination method. Notice that if we add these equations as they are, the x's aren't eliminated, the y's aren't eliminated. We need to first modify one or both of these equations in order to use this method. So what we first want to do is figure out the most efficient way to do that. If we look at the x's, we have a 9x and a 2x. Remember, we can multiply an equation by a number. We just need to make sure we multiply the entire equation, both sides of the equal sign, by that number. Is there something I can multiply 9x by to make it 2x? No, not unless it's a decimal. How about 2x? Is there something I can multiply 2x by to make it 9x? No. So we would have to multiply both equations by numbers in order to make the coefficients for the x's be the same. Let's look at the y's and see if that's easier. We have a 3y and a 1y. Notice that we can multiply 1y by 3 or negative 3, and then we can easily add these two equations together and eliminate the y's. Let's see what that looks like. If we multiply the second equation by negative 3, again, remember, you can multiply an equation by a number, but you need to multiply both sides by that number. So 2x times negative 3, y times negative 3, and 5 times negative 3. And then let's just leave that first equation as it is. Now, if we add these two equations together, we have 9x minus 6x is 3x, and the y's are eliminated. 3y minus 3y is 0. And then 12 minus 15 is negative 3. Now we have an equation that we can solve because there's only one variable. So if we divide both sides by 3, we see that x is negative 1, which is part of our solution. Now we need to figure out what y is when x is negative 1. And we can look to either one of those original equations, whichever one happens to look a little easier to you. So I'm going to pick the second one, and I'm going to substitute in negative 1 for x. And now again, we have an equation that just has one variable. We can now solve this equation for y. So the first step is to simplify both sides. If there's anything to distribute, any like terms to combine, we do that first. Then you start moving things away from the variable. And when we do that, we see that y equals 7, the other part of our solution. The last step is to just write our answer as an ordered pair. So when x is negative 1, y is 7. If you were to graph both of these equations, you would see that they intersect at this point, negative 1, 7. Negative 1, 7 is one of the many solutions to the blue equation and one of the many solutions to the green equation, and it's the one solution that they have in common. So it's the solution to the system of equations.